Your schedule passed every check. The logic looks complete. The critical path reads cleanly. The quality score is green. So it's trustworthy, right? Wrong. Because structurally clean and actually achievable are two completely different questions. A schedule can be flawless on paper and still be a fantasy. The durations might be optimistic, with a 1 in 20 chance of hitting the date. Answering all three questions, is it sound, is it likely, can it be saved, takes more than a tool. It takes a deliberate assurance process. Welcome back to Catalyst Grid. Over the next 14 episodes, we'll turn schedule assurance into a repeatable discipline built around Deltek Acumen. It starts today with the core idea. Quality, probability, and recovery are three separate questions, and no single step answers all three. I'm Kingsley Amufua, and this is Schedule Assurance with Deltek Acumen. If you followed Season 1, welcome back. This season assumes you already understand the basics: critical path, float, logic, and the data date. If you're new, start with Season 1. This series is for two kinds of people: the planners running the software and the PMO leads commissioning the analysis. Every episode does two things. It shows the operator how, and it tells the decision maker so what. Let's clear up some confusion. When people say Acumen, they usually picture one tool. It's actually a family, and the jobs are genuinely distinct. Product 1, Acumen Fuse. This is the quality engine. It checks logic, float, constraints, and calendars. Is this schedule credible? Product 2, Acumen Risk. This is the probability engine. It runs Monte Carlo simulations to give you confidence levels. Product 3, Acumen 360. This is the recovery engine. It models how a project might be pulled back toward a target. And Product 4, Acumen Touchstone. Automated checking when a contractor submits a program against your standards. We'll focus this season on the first three: Fuse for quality, risk for probability, 360 for recovery. 3 engines, 3 questions. Now the order you use them in matters enormously. This 11-stage pipeline is the backbone of the entire season. You import and validate that the data is clean. You diagnose quality and correct material defects. This is where Fuse starts. Only then do you compare versions and benchmark for context. Now that it's sound, you risk adjust it for uncertainty. From the risk results, you develop mitigations and model acceleration. You approve at a chosen confidence level and publish. Here's the rule: you cannot skip stages. Risk adjust a schedule you never diagnosed, and you've built confident nonsense. Garbage in, sophisticated garbage out. That principle is why we'll walk this pipeline, stage by stage, for 14 episodes. Strip away the software, and schedule assurance is really just 3 questions asked in order. Question 1, is it credible? Is this schedule built well enough to believe? Logic, progress, constraints, calendars. That's the Fuse question. If it's no, nothing else matters yet. Question 2, is it likely? Given uncertainty, what's the real probability of hitting dates? Not one number, but a range. That's the risk question. Question 3, can it be recovered? If we're exposed, what are the ways back and what do they cost? That's the 360 question. None of these tools replaces judgment. Fuse doesn't decide if a constraint is legitimate, you do. Risk doesn't pick the confidence level, management does. The tools screen, quantify, and optimize. People decide. Anyone who tells you the software gives you the answer has misunderstood its purpose. By the end of 14 episodes, you'll be able to take a raw schedule and run it through the complete assurance pipeline. You'll set up a workbook that keeps baseline, updates, and scenarios cleanly separated. You'll run a full quality diagnosis, logic, float, progress. You'll compare versions forensically and finally answer the question: why did the completion date really move? You'll build a defensible risk model, uncertainty, risk registers, and read outputs like a pro. P50, P80, and the tornado chart. And you'll model recovery scenarios that are physically real, not just mathematically convenient, retesting them under risk before you believe them. That's not a software tutorial. That's a professional capability, the kind that makes you the person a troubled program is desperate to find. First, this is a hands-on season. Wherever you can, follow along in your own Acumen environment with a real schedule. Doing it is where it sticks. Second, Acumen is highly configurable. Libraries and thresholds can be customized. Treat my descriptions as the concept and confirm your local settings. Third, keep a notebook, because this season produces artifacts, checklists, registers, and templates that become your actual working toolkit. Fourth, watch in order if you can. The pipeline has hard dependencies. Episode 7 assumes Episode 4. Risk assumes quality. Don't skip ahead. Let's lock in today's takeaways. 1. Acumen is not one tool, it's a family. Fuse, Risk, 360, and Touchstone. Now you know the difference. 2. There's a pipeline, and the order is not optional. Each stage assumes the last was done right. Skipping stages produces confident nonsense. 3. Underneath are 3 questions. Is it credible, likely, or recoverable? The tools don't replace your judgment. You decide. So, my question for you. Which question does your organization answer today? Comment quality, probability, or recovery. I want to see where we sit. Subscribe, because next episode we start building. Setting up the Acumen Workbook, import, mapping, and the version control that makes everything trustworthy. 90% of bad analysis is decided in the import. Next week we get it right. I'm Kingsley Amafua. This is Catalyst Grid. Assure the schedule. I'm going to tell you something that sounds impossible. Most bad schedule analysis is decided before a single metric ever runs. Not during diagnosis, not in risk, in the import. Because if the wrong date comes in, if the baseline isn't assigned, if the calendars don't map, then every clever thing you do afterward is built on a broken foundation. You'll produce a beautiful, confident, completely wrong analysis. Garbage in, sophisticated garbage out, exactly like I promised last episode. So today, before we diagnose anything, we get the foundation right. The Acumen Workbook structure, naming conventions, and the mapping checklist that guarantees your data integrity. Welcome to Catalyst Grid, and my name is Kingsley Amafua, your host. I'm Kingsley Amafua, and this is Schedule Assurance with Deltek Acumen, Episode 2. Last episode we mapped the season. Today we're on Stage 1 and 2 of the assurance pipeline, import, and the start of validate. We're at the very front of the process. The container for all of it is the workbook. The workbook is your central analysis file. Think of it as the whole project's assurance workspace in one container. It holds far more than a single schedule. A workbook contains imported projects, versions, snapshots, metric libraries, analysis views, and risk inputs. When you import a schedule, the data is stored inside. That means you can analyze it offline. Your planner can keep working in P6 while you analyze a snapshot in Acumen. Because a workbook can hold multiple snapshots side by side, it's built for comparison, this month against last month. The contractor's version against the baseline, all in one file. Nothing destroys trust faster than not knowing which schedule you're looking at. First, we need a naming convention. Every workbook name should tell you exactly what is inside. For example, project code, Acumen, review type, data date, and revision. Read that file name and you know exactly what it is without even opening it. No more final or really final. Second, a standard set of versions inside every workbook. I use 6. Version 1, the contract baseline. Version 2, the previous accepted update. Version 3, the current contractor update. Version 4, the planner corrected scenario where you fix defects. Version 5, the risk-adjusted scenario. And version 6, the recovery scenario from Acumen 360. Same structure, every project. Once your whole team uses this, anyone can open any workbook and instantly know what each version is. That standardization makes every analysis trustworthy and repeatable. Acumen works with major planning systems, Primavera P6, both XER and XML formats, Microsoft Project, Deltek Open Plan, Phoenix, and Saffron. It has a very broad reach. But here's the rule. Import the XER or the XML, not a PDF. A PDF is a photograph of a schedule. An XER is the schedule. You cannot diagnose logic from a photograph. Specify the native format up front. Ask for the XER or XML with the baseline included. This saves you a painful round trip later when you find out the file can't be analyzed. When the data comes in, do not just click through. Confirm each step. Is the project correct? Is the data date right? This is critical for the forecast. Is the correct baseline assigned? Did the calendars import? Is the WBS structure intact? Did the activity codes land in the right fields? Are the relationships and constraints all there? Check them all deliberately. And are the user-defined fields, the UDFs, mapped correctly? If a custom field for responsible party lands in the wrong slot, your filtering later will quietly lie to you. Mapping is not a formality. It's where you make Acumen's understanding match the planner's intent. Skipping this can invalidate a week of analysis without you even noticing. Setup sounds technical, but it's vital for managers too. Every quality score or forecast you see inherits its credibility from the import. The right question is, was the import validated? As a decision maker, insist on three things: native files, validated imports with baseline confirmed, and version discipline. These protect every decision you'll make downstream. This is the foundation. It's not exciting, but excitement built on a bad foundation is just risk you can't see yet. Now let's lock in the takeaways. 1. The workbook is your workspace for offline analysis. 2. Name and version everything using the 6 version standard. 3. The import is the foundation. Always use native files. This week's action: set up one workbook with the standard 6 version structure. And comment below, are you a P6 shop, Microsoft project, or something else? I want to know. Subscribe, because next episode we finally start reading the schedule. The characteristics scan. The 30-second read of vital signs that tells you the truth about its health. The foundation's laid. Next week we diagnose. I'm Kingsley Amafua. This is Catalyst Grid. Assure the schedule. 3 defects hide inside almost every schedule I've ever reviewed, and they hide in plain sight. The first is invisible at a glance because it lives in the summary statistics nobody reads past the headline percentage. The second is invisible because it's an absence, a missing link that looks like nothing, which is exactly the problem. And the third is invisible on purpose because it has no name, no owner, and no way to ever report its own progress. Vital signs nobody reads properly. Logic gaps nobody notices because there's nothing there to notice. And hidden work, quietly living inside a relationship instead of out in the open where it belongs. Today is a long one, because these 3 defects are really one investigation, the diagnostic heart of Acumen Fuse, and I wanted to give it to you in one continuous sitting instead of 3 separate videos. Part 1. Reading a schedule's vital signs before you diagnose anything. Part 2. Hunting logic gaps and judging whether every relationship earns its place. Part 3. The leads and lags where hidden work loves to hide. Get a coffee. This is the episode that turns you into someone who can actually read a schedule, not just look at it. Welcome back to Catalyst Grid. I'm Kingsley Amafua, and this is Schedule Assurance with Deltek Acumen. Quick anchor before we start. Episode 1 gave us the 4 products in the 11-stage assurance pipeline, import through publish. Episode 2 got the workbook, the import, and the version control right. We're now deep in stage 3 of that pipeline. Diagnose. And diagnosis is a big enough job that I'm giving it to you as one long, complete sitting. 3 parts, 1 video. Part 1, the characteristic scan, reading a schedule's vital signs in the time it takes to glance at a dashboard. Part 2, logic integrity, finding the gaps and judging every relationship on its merits. Part 3, leads and lags, the invisible durations where entire chunks of real work quietly go missing from view. Each part stands on its own, but together, they're the complete first pass of a Fuse diagnostic review. Let's start with the vital signs. Before you diagnose anything, you take vital signs. A doctor doesn't order a scan before checking pulse, temperature, and blood pressure. And a professional schedule review doesn't run a full metric library before it's looked the schedule in the eye. That first look is the characteristic scan. And it takes less time than reading this sentence took to write. Here's what you're capturing: the activities, milestones, and relationships, counts, the overall duration, and the data date, the planned completion, the critical path duration, and the longest path. And yes, we'll come back to why those aren't always the same thing later this season. The number of calendars in use, percent complete and remaining duration, negative float if there is any, the shape of the total float distribution across the whole network, the count of constraints, the count of open ends, and the count of lags, leads, and out-of-sequence activities. None of that requires running a single metric. It's a snapshot, and it's astonishingly diagnostic on its own. A schedule with 400 constraints is telling you something before you've investigated a single one of them. A schedule with 400 open ends is telling you something else entirely. Take the vital signs first. They tell you where to point the deeper investigation before you begin. Take the pulse before the scan. Now you run the actual metric library. And here is a habit that will save you from the single biggest mistake in this entire discipline. Do not stop at the headline percentage. The run gives you an overall score, but underneath it sits a metric level score for every individual check. A count and a percentage of failed activities. A trend against the previous update. Is this getting better or worse cycle over cycle? A concentration view. Are the failures spread evenly, or are they clustered in one WBS area or with one specific contractor? Look at the split between critical and near-critical failures versus failures buried somewhere with plenty of float. This distinction matters enormously because a defect on the critical path is a live threat to the finish date. The same defect in a low float branch might be background noise. And here's the judgment call. For every failure, ask whether it's structural, a build defect, contractual, a requirement, or an agreed exception. Treat them all the same way and you'll either overcorrect reality or you'll wave through genuine structural rot. The score screens. It does not conclude. So you drill down. For every material failure, and I stress material, capture a consistent set of facts. The activity ID and name, its WBS location, which metric it failed, the actual reason for the failure, the program impact if left alone, the recommended correction, an owner, a due date, and 6 standard dispositions cover almost everything. Correct, accept as justified, monitor, refer to contractor, refer to lead, or not applicable. Building this register turns a diagnostic score into an action plan instead of a number on a slide. Notice something important. You've just built the connective tissue for the rest of this season. Every deeper investigation follows this same discipline. Capture, investigate, disposition applied to one specific type of defect at a time, which brings us to part 2. Logic integrity. The scan found the suspicious links. Now we hunt. Part 2. Logic integrity. The characteristic scan found the suspicious links. Now we judge whether they earn their place. Logic is the schedule's nervous system. Get it wrong, and every float number in critical path finding is compromised from the ground up. So let's go hunting. An activity with a hole in its logic isn't a schedule entry anymore. It's an independent guess wearing the costume of a calculated date. Here's what we're hunting for specifically. Activities with no predecessor, no successor, or neither. Logic chains that trail off without ever connecting back. An activity without complete logic doesn't move when things around it change, because nothing is telling it to. Its dates become an isolated forecast. Procurement slips 6 weeks. Everything shifts, but the orphan stays put, looking calm while it's actually a lie. It's the most dishonest date in the network. Now, before you declare war on every open end, know the legitimate exceptions. A blanket, 0 open ends rule applied blindly causes its own damage. The project start milestone has no predecessor. Final completion has no successor. These are correct. Milestone icons get justified stamps. The foundation's laid. Next week we diagnose. I'm Kingsley Amafua. This is Catalyst Grid. Assure the schedule. Start to finish is rare because it reads backwards. Watch for patterns where non-standard links are overused as shortcuts. Watch for activities with only SS predecessors or FF successors. Nothing constrains their other end. And watch for relationships that bypass entire work packages. Start to finish is rare, and it should be, because it reads backwards to almost everyone who looks at it. It's counterintuitive. Here is the single question I want you to run every relationship through, because it cuts through almost every logic problem you'll ever find. What physical, contractual, design, approval, or commissioning dependency prevents this activity from happening earlier? That is the gate. If you can answer that clearly, the relationship is probably sound. If the answer is, that's just how the planner typed it, you found either a missing relationship or one that shouldn't exist. A tool tells you a link exists. It cannot tell you whether the relationship is telling the truth. Now, part 3. Logic integrity solves missing connections. But there's a quieter defect sitting right inside the correct ones. Part 3. Leads and lags. It's the gap between activities where entire chunks of real work go to hide in plain sight, because a lag looks like nothing at all. Leads and negative lags. Start with the more dangerous cousin. A lead is effectively a negative lag, letting a successor begin before its predecessor has actually finished. Picture: install equipment, finish to start, minus 10 days after delivery. It says installation starts 10 days before delivery completes. Tidy on paper, but obscuring reality. Reality is delivery in batches. The fix is decomposition. Split the vague lead into real activities you can actually see and manage. Deliver batch 1. Install batch 1. Complete deliveries. Complete installation. Each one is now reportable, with its own owner, replacing one negative lag shortcut. Positive lags aren't automatically a problem. Genuine waiting periods exist on every project, and a lag is often the right way to represent them. Concrete curing time, a formal review period, shipping duration for long lead items, statutory notice periods, testing soak and mobilization delays, real elapsed time. But here's why I'm still suspicious. A lag lacks almost everything a proper activity has. No owner, no progress record, and no cost. Critically, nobody reports on a lag, ever. It just sits there, silent for the life of the project. Activity maintenance loop versus lag silence. Suspicion is healthy. If it's observable work or a wait, model it as an activity. Be specifically suspicious of long lags. 60 days is often just hidden work, or worse, a fudge number typed in until the dates on screen looked acceptable to somebody. That is a major risk hiding in plain sight. Review discipline. Build review discipline. Every retained lag should have a documented reason and source. Don't let long lags hide. Treat every lead with real scrutiny. It's quietly asserting that a dependency doesn't fully apply. Often, it's just optimism dressed up as a number. Scrutinize them both. Bring it together. Bring it. Let's bring all three parts together. 1. Take vital signs before you diagnose. Never stop at the headline percentage. Give failures a disposition. 2. Logic is the nervous system. Hunt the holes, but respect milestones and LOE. 3. Lags have no owner. Model work as activities. Treat long lags with suspicion. Put together, these three parts are the complete first pass of a Fuse diagnostic review. This week's challenge: post one surprising vital sign, your genuine open-end count, or your longest lag. Comment your choice. Subscribe for next week's constraints and float. I'm Kingsley Amufua. Assure the schedule.